All right, my pretty people, we've got lesson 9.3.4, combining functions. All right, so we've got three functions. C of x is 3, so that's linear. That should be like a horizontal line going through 3. We got f of x equals x squared. That's the parent function for a quadratic, so that's going to make a parabola. And then g of x equals 2x plus 1, so that should be a linear function that's increasing. And it looks like it should be going through 1 on the y-axis. Okay, so what we're going to do is we're going to combine these functions using different operations and see what they make when we combine them together. So first one, to find a of x, we're going to take f of x and c of x and add them together. So these are just the outputs, remember, for them. So a of x, f of x is 3. C of x is, no, that was, f of x is x squared. Messed that one up. All right, so we get x squared plus 3. So when I added a constant to this quadratic equation, I still have a quadratic equation. The change is this one was at 0, 0 for the vertex. This one got shifted up 3 units. So when I add a constant, I'm going to shift it up or down. Next one, b of x. B of x is equal to c of x, which is 3. I'm getting it right this time. And then I'm going to multiply it by f of x this time, which is x squared. Okay, so when I multiply that, I get 3x squared. So on this problem, I still have a quadratic, but now the a value has changed. It's not shifted up anymore. The parabola, like if f of x, the parent function, looks like this, remember when the a value gets bigger, it pulls it in and it becomes tighter. It pulls in the two sides of the parabola closer to each other. So it kind of becomes steeper, or the rate of change increases for it. So by multiplying it with a constant, I haven't changed the vertex, but I have changed the sides. The sides are pulled together closer from that one. So it's still quadratic. G of x minus c of x. So here's g of x. G of x is 2x plus 1. And then I'm going to subtract c of x. C of x was a constant. So I've got a linear function here that I'm subtracting this constant from. And 2x plus 1 minus 3 is 2x minus 2. So this is a shift down. This was used to have a y-intercept of 1. And all I've done is shift the graph down 3 units. So now the y-intercept is negative 2. So it's still linear. I know it's a linear because it has an x to the first in it. This one has an x to the second, making it a quadratic. That's making a parabola when we do that. All right, next one, c of x times g of x. All right, so e of x equals c of x is 3. And we're going to multiply it with g of x, which is 2x plus 1. So I'm going to have to distribute this and get 6x plus 3. So this is still linear. But what's changed is not only has my y-intercept gone up to 3, but now I have changed the steepness of my graph as well. So remember, if we've got up 2 over 1, it usually looks like something like that. Well, this one, the y-intercept increased and it got steeper. All right, 9-115, we're going to look at these two functions, x squared and 1/2 x plus 1. So we've got a linear function and a quadratic function. So here's my linear, h of x. My quadratic is x squared. I'm going to use the resource page and fill in f of x and c of x and then graph them on the first graph. All right, so I'm going to flip it over. Part A says I'm going to fill in f of x and h of x and then graph them. All right, so if I plug in -3, -3 squared is 9, -2 squared is 4, -1 squared is +1, then 0, then 1, 4, 9. For h of x, if I plug in -3, that gives me -1.5, plus 1 would be -0.5. If I plug in -2, that gives me -1 plus 1, so that's 0. If I plug in -1, I get -1/2 plus 1, so that's +0.5. If I plug in 0, I get 1. If I plug in 1, I get 1.5. Plug in 2, I get 2. If I plug in 3, I get 2.5. So you can see here on the linear one, we're just increasing by 1/2 each time because our slope is 1/2. Okay, it says to graph that on the same graph. So let's start with f of x. I'll do that in light blue because I feel like it. So it looks like at -3, I get 9. That's off the graph, so somewhere up there, way up there. Let's plug in the next one. So -2 and 4, get that point. 1, 1, 0, 0, 1, 1, and 2, 4. All right, so I've got my parabola there. All right, not bad. I've done better. Anyways, there we go. There's my parabola. My other graph, if I plug in the points, -3, -0.5, that's right here. And then I've got -2, 0, -1.5, 0, 1, 1, 1.5, 2, 2. Yeah, 2, 2. Starting to second guess myself here. All right, and there's my linear equation. So this is h of x, and this one over here is f of x. All right, we did part A. Congratulations. Part B. Fill in the table for j of x and k of x, and then graph them on the same graph as before, so the one that we just did. So j of x and k of x. Okay. So in j of x and k of x, we are adding the outputs together. Now, I don't have to re-plug in. Like, I know that f of x plus h of x would be x squared plus 1/2 x plus 1. But I already know the outputs. That's what f of x stands for. So I can just do 9 minus 0.5, because I'm adding these two together, and I would get 8.5 here. Add these two outputs together, f of x and h of x. I get 4. Add these two outputs, 1.5. Add these two outputs, I get 1. Add these two outputs, I get 2.5. Add these two outputs, I get 6. Add these two outputs, I get 11.5. All right, let's graph j of x and see where that gets us. So -3, 8.5, that doesn't fit, so we won't graph that. Next one would be -2, 4. So -2, 4 goes right there. Next one is going to end up being -1, 1.5. That'd be right here. Next one is going to end up being 0, 1. Next one's going to be 2.5. Next one's going to be 6. And then it's off the graph. All right, so we can see here that each of these points is just the other 2 points added together. See, we've got 0 and we've got 4. That's why that point was at 4. Here we've got the 2 points originally were 1/2 and 1, so that's why we got 1.5 there. Now this is making a parabola. It's just that the, what's it called? Why can't I think of words today? It's just that the vertex, that's the word I was looking for, the vertex is somewhere over here. So this one's going to kind of come down like this, turn around, and go back over to there. So there's the new parabola. Wow, that was really bad. Okay, but we're going to be fine with it. So adding the linear and the quadratic together has shifted the vertex of our original graph there. Okay, so for k of x, f of x, k of x is f of x minus h of x. So this minus this. So I do this minus negative that. So that would be 9.5. 4 minus 0 is 0. 1 minus 0.5 is 0.5. 0 minus 1 is negative 1. 1 minus 1.5 is negative 0.5. 4 minus 2 is 2. And then 9 minus 2.5 would be 6.5. Okay, graphing those ones. 3 is off the graph. Too bad. Here we get this point right here. Next point would be at negative 1 and 0.5. So negative 1 and yeah, it's right here. Next one would be negative 1. So, we're at 0, negative 1, right here. Next one would be at negative 0.5. Next one would be at 2. 2, right here. Next one would be at 6.5. That'd be right here. I think I messed up somewhere in here. Pretty sure I did. Maybe I messed up here. I don't know. Oh, wait a second. 4 minus, 4 minus, I did 4 minus 4. It's 4 minus 0. Duh. That's 4. I knew I messed up somewhere. So it's not right there, sorry. It's right here. All right, so what do we have here? Here's another parabola, but this parabola is just down here. And you see how these parabolas are going. They're kind of going parallel there. You see all those vertexes? It looks like it's all parallel to that original line. See that pattern of it moving? So here I'm adding the number, here I'm subtracting the number of those parabolas. So I still have a parabola when I do that. All right, last one, we're going to do, let's see, what's our last thing? All right, what do you notice about the new graphs? Okay, so I noticed that there's still parabolas. And if we connect all those vertices, if we connect those vertices, this is really interesting. If we connect those vertices together, look, it looks like that line connecting the vertices is perpendicular to the line that we were subtracting from the quadratic there. So you see how it's just kind of shifting back this direction. So here was our original vertex. We shifted it this way when we added it. We pulled it back to here when we subtracted it. All right, so that's when we have addition and subtraction between a quadratic and between a linear equation. Now we're going to multiply those. I didn't finish that, but let's just finish this up. All right, so now we're going to multiply them and see what happens when I multiply a linear equation with a quadratic equation. So I'm multiplying these two numbers. So 9 times negative 0.5, that's 9 times negative 1/2. That comes out to negative 4.5. 4 times 0 is 0. 1 times 0.5 is 0.5. 0 times 1 is 0. 1 times 1.5 is 1.5. 4 times 2 is 8. And 9 times 2.5 is 18 plus 4.5. That would be 22.5. All right, so now we're going to graph those. So I've got -3, -4.5. Okay, we're not going to be able to fit this, but let's try to get it in there anyways. Let's say that's -3 right there, -4, -4.5, let's call it right about here-ish. That sounds good. All right, so that's -4.5 right there. Next one would be at 0. Next point that we did is 1/2. Then we're back at 0. Then we're back at 1.5. And then we're up at 8. That's somewhere over here. So this is really interesting. Here's what's happened. If we connect these points together, what we get is something like this. I didn't hit it correct, but close enough. So we get this weird graph here where it's changing directions twice. So this is what's called a cubic graph. Now, why is that a cubic graph? Well, if I took those equations and multiply them, so f of x was x squared, and if I multiply that with the linear equation of 1/2 x plus 1, if I distribute this, I get 1/2 x to the third plus 1x to the second. We've got an x to the third now when we multiplied these. This is not a parabola anymore. This is a graph that changes directions twice because it's now what's called a cubic function because we've got the third power there. So when we multiply those two functions together, it's neither a quadratic nor a linear equation anymore. It's turned into it's turned into a cubic function, and cubic functions always kind of do something like this, where they change directions twice. It's like one side of the parabola got flipped around. So you're always going to get it changing directions like that. All right, I think that's enough for today. Math hard. See you later. Bye-bye.